department at California State University, Fresno. We are supposedly having 5 presentations today. I'm assuming 2 of the authors haven't registered or haven't picked up the registration, which means they might not be around, so we'll see how it goes. So the first presentation, again, you have 15 minutes to present. I will give you a signal when you have 3 minutes left so that you can wrap up and leave some room for questions. I'll stand up after 15 minutes so that you can continue. There is a pointer, as I told you can use the pointer. And the presentations that I was provided are going to be here. So please start.
Thank you. Hey, everybody. I am Alejandro. I came from Mexico Institute of Technology in the campus of Celaya, Guanajuato. And I came here to talk about the Jetson starter kits to do image processing in parallel. So we did a comparative, and I would like that you are very interested in this topic. So the presentation is the introduction and materials and methods, results, discussion, and conclusions. I want to be very fast. So NVIDIA has 2 very new products. About 3 or 4 years ago, they delivered these products. One is the Jetson Nano, and the other is the Jetson Tx2. To do artificial intelligence here with using GPUs to process the image and something like that. They say that these products are designed to do autonomous machines, and they also put inside some CPU and GPUs to do processing. And why we are doing this? We want to use that because we are doing quality control of metal sheets to automotive industry. So we have to detect the defects before the metal sheet has a fracture. So it's very important to us to do image processing, and the important topic for this is the 3D image reconstruction. So we have to use multi-cameras, at least 2 cameras to do stereo vision. So the very main important problem in stereo vision is the point matching. So we have to relate the one point in left image with the same point in the right image. So the template matching come here to appear here to detect that point in both images. So here we have a group of 100 points, and for each point, the searching must to be in all the second image. So it's very, very, very heavy process. What is template matching? So template matching is a very useful operation that searching a piece of image in another image. So we could, to test this method, we cut a piece of this image and searching in all image, like in these pictures. So we have to slice the template along all the image that we want to find that template. So this problem also is very important now to use in deep learning, like convolutional neural networks. So we have to do convolutions in all the images, and that's why this problem is very important. So we have a experiment here where we use different size of image where we want to find the template, the QV, HG resolution, SD resolution, HD resolution, and others, still 4-key resolution. And we do two different experiments with fixed size template and variable size template. The fixed is 50 by 50, and the other is variable, according with the size of the image where we want to find the template. So we can guess the difference between two platforms, but because we have the characteristics, the features given by the NVIDIA. So, but we want to know the real behavior, the real performance of these platforms to do template matching. Is the key operation for us. So we got some results, some difference. We also do the same operations in the CPU and in the GPU of both platforms, on Tx2 and on Nano. And we also did the different template matching methods, do it by opencv library. So we can see that there are small differences in times, and we can see the times of CPU are slow, more slow than the time of GPU. The GPU is the dotted lines. And also, in different cases, when the template is with the same size, and when the template has the different sizes. So we can see that in the QVHA resolution, and we have it also for all resolutions, for SD resolution, and the behavior is similar, but the time is different because this is very small image, and SD is bigger, and the HD is bigger, the FHD is bigger, 2K is bigger, 4K is bigger, and we can see the behavior is quite similar between equal to template and proportional template. So we believe that for our experiment is just like the same these behaviors. So we did a comparative with a ratio using the nano ratio and Tx2 ratio here for the CPU, and we found that the difference is about 1.5 between Nano platform and Tx2 platform. So with different resolutions and with different methods of template matching. And also we have the times, the ratio between times on GPU for nano between Tx2. In the case where the template is fixed, so the size of the template is fixed. So we find about 3 times slower the nano platform is slower than the Tx2. So we also did it for the variable template, and we found it that it is also 1.5 about the difference between 2 platforms. Here, CPU Tx2. Okay. This is with GPU. That is the interesting point for us. To do processing on GPU between nano and Tx2, and the time is low, more about less than 3. The relation is less than 3, and we have some conclusions that on average the Jetson Tx2 is 3 times faster than the Jetson Nano for the opencv correlation processing when GPUs are used. And it also experimented with the CPUs of both kits, and although they have slower than GPUs, they also process modestly fast. Regarding to the use of the template image of constant and variable size, in the test carried out, there was not a considerable variation in the processing times when one or the other is used. This work is expected to be useful when it's required to decide which key to use in template image processing projects. And I believe this is also important, the relation between price in Tx2 Jetson and Nano Jetson is 5, and the time for processing these methods are 3 between Tx2 and Nano. And also with this data, we guess that it could be possible to do a cluster with nano platform, that it could be competitive with Tx2 platform. So I believe this work could be interesting for you and useful. Thanks.
Thank you. Any questions? We have 20 minutes for questions, please. I don't think the second presenter is
So I'm not familiar with the Jetson platform. So in one of your earlier slides, you had listed 2 cores for the Tx2 for the CPU, 2 CPU cores.
You say about...
maybe it was slide 3 or 4 or one of the earlier...
You say about this?
Yeah. So what is the second one, the 2-core Denver 2? No, first row, the CPU, yeah.
CPU, this one?
Mm-hmm.
I don't know exactly. I only put the features that NVIDIA shows for us.
It actually has 2 multi-core processors. So one's a quad-core, one's a dual-core, plus the GPU on the board. So it actually, the Denver processor, if I remember correctly, the Jetson, it's for specific ports on the board.
Oh, is it a real-time processor?
Yeah.
Oh, okay.
Yeah.
Okay.
That's why it's a very good platform to do parallel processing and image processing. Yeah.
Also, actually, that brings me to my other question, if I may. Continue.
You have time. Yeah.
So, what are you described this application for the metal sheets and the point matching. what are the performance requirements of the application? Like how fast is it necessary to do it?
Oh, yes, very interesting question. We have already a prototype that do it in 40 minutes with normal CPUs. And is working with images of 4K. And it's very, very slow. But the it's this quality control is do it out of line. Offline. Yeah, it's make it offline. So the time is not very important now because they want only to know the quality of the metal sheet in a sample of all the stack of that sheets. So, but it could be good that this process will be implemented online with the machines that deform the sheet. So they could check all the sheets and check the quality of all of them. Yeah.
So if it takes 14 minutes, right, to do
40.
40.
Yeah.
Right. So how big is the mesh?
About 1 meter by 1 meter.
Okay, and it's done with the same type of cameras that you're.
No, no, they are using different methods. We have a prototype, and they are working with a system called Argos, and that system is made in 40 minutes. And our platform in MATLAB and CPU, it takes about 10 minutes to do the processing. And now we want to reduce that time. Yeah, and I forgot your question.
No, I wanted to know the size.
The size, yeah. Yeah.
So actually, to piggyback on that question, I have a question.
Yeah.
Talking about the camera, you didn't cover about the data that you used. Like, how many images did you use to get these benchmarks? Is it just a single image with different qualities, same image?
Okay. For this experiment, we
Yeah.
use a stereo vision, so we only got 2 images.
Okay.
We put the metal sheet on a table. So and then we put 2 cameras with 4K resolution and took the.
So same camera but different resolutions, but same image.
Okay. Yes. Yes. And we did the different resolutions by artificial method. opencv reduced the resolution automatically if we want.
What's the impact of lowering the resolution to the quality of inspection?
Very, very hard impact. Because if we are measuring this in micrometers, the resolution give that possibility. If we reduce that resolution, I don't know exactly what's the impact in micrometers or millimeters, but it reduces it too.
Will it be better than what they are currently using with the other brand, the other equipment they have? I mean, I know your goal is to be faster.
Yeah.
But is it going to also increase the quality of the inspection?
Yeah, yeah.
With the Jetsons.
Yeah, because we can add more cameras. We are using now 2 cameras, but if we use more cameras, the accuracy it's better. And the parallel processing also is important. For the Argus platform, they use a very big server to do the processing because it's a quite old equipment, about 10 years ago. So the processing is very heavy, and they use a server. And we want to use also Jetson platforms to reduce the size of the system and give some portability to do a lot of that kind of apparatus to in the future do it online, the quality control. Yeah. Yeah.
Is there any data on the actual platform resources used in these experiments?
I don't have
How
it.
many cores have been used on the nano? How many cores have been used on the Tx2? Right, because this comparison also depends on actual platform resources. In other words, if you have like 40 cores
Yeah.
used in both, then it doesn't really, you don't take advantage of Tx2 at all from this viewpoint. On the other hand, if you have applications with the tool chain is able to parallelize on, I don't know, 200 and something cores. So that's why, I mean, this would be relevant in some sense, this kind of platform usage statistics.
Yeah.
Was it ever used at all?
Like, do you know the percentage utilization?
Yeah, the usage, the accuracy would be very good, like additional parameters to add dimensions to the analysis.
Yeah, I don't have that analysis, but that's why we did this.
Can you get those statistics? I'm sorry, I'm not familiar with the platforms of the tool chain.
Well, opencv doesn't support it, but it can be done through the platform itself.
Yeah.
Yeah, you can get this kind of statistics, right?
Jetpack's a pain to work with.
Yeah.
And that's just the OS that runs on it, but it's just a Unix derivative. It's just a pain. So I don't know if you actually have access to all of that data.
Okay.
Do you know how well this would scale to running neural networks versus like this pattern, the pattern matching? Like how the computation scales to other sort of loads?
No, I don't know. We used experiment with this type of processing, and maybe we will do it in the future. But this is because these platforms are designed for artificial intelligence.
Yeah.
But in our case, we are not using artificial intelligence, so we don't know now how to difficult, what the time, and something like that. Yeah, yeah, it's a quite different way that we took to use these platforms. Yeah.
Yeah, thank you.
Thank you.
Great handling questions. Sorry for grilling you. So,
Thank
do
you.
we have anyone from the second paper towards deep learning based traffic action